So you already know how to find a limit graphically. You know how to find the limit by using a table. Now we're going to learn how to find limits algebraically, or sometimes you'll hear analytically. And we're also going to find limits of composite functions. So the very first thing on your notes that I gave you was your first option will always be to use direct substitution. Here's what direct substitution means. If I have a function like this one, 3x minus 2, and I'm finding the limit as x approaches 1, the first thing you're always going to try is see if you can just directly substitute the number in. So I'm going to say 3 times 1 minus 2. So 3 minus 2, 1. So the limit of that function is 1. Now the reasons why you would not be able to use direct substitution is if you directly substitute something in and got 0 in the denominator. These, they're not even fractions, so I can use direct substitution on these. Example 2, find the limit as x approaches 2 of 4x squared plus 3. So using direct substitution, I'm going to substitute my 2 in. So 4 times 2 squared plus 3. Don't forget to follow the order of operations, so I'm going to do my 2 squared first. So 4 times 4 plus 3, 16 plus 3, 19. Okay, so those were pretty easy. It's just like evaluating a function, but we're going to substitute those in. Now, if we were to graph those or use a table, we would come up with the exact same answers. Okay, example 3. This one looks a little different. Here's what they've given us. They've already worked the problem for us. They're finding the limit as x approaches some number of f of x, and they said that my answer is 3. Here's my second problem. The limit as x approaches that same number of g of x, so they're just saying two different functions. This time my answer is 2. So we're going to use the properties of limits that we talked about in class. The properties of limits say that I can multiply 5 times this limit, and I can do that. So I'm going to find g of x. What is the limit as x approaches c of g of x? Well, it's 2. They already gave me that answer. So I have that 5 out in front. 5 times 2, so the total limit is 10. Okay, this one says if I have two different limits, I can find the two limits and add my answer together. So I'm going to find the limit as x approaches c of f of x, which was 3, plus the limit of g of x, which is 2, so my total limit is 5. Okay, part C. This is another property of limits. If I have two different limits being multiplied together, find the limit of each and multiply my answer together. So the limit of f of x is 3. The limit of g of x is 2. And I got those from up here again. So my total limit is 6. Down here, same thing, using my properties of limits. I'm going to find the limit of f of x. It's 3. The limit of g of x is 2. And we can just leave our answer just like that. So you need to be filling these in as we go along on your paper. So those are easy. We like those. Okay, you're basically just substituting numbers in, and we can do that because of properties of limits. All right, let's look at the next example. Example 4. These are called composite functions, and you actually did composite functions in Algebra 2. So we can find the limits of composite functions the same way. Here's part A. The limit as x approaches 3 of g of f of x. These two things are not being multiplied together. They're composite functions. Here's my f of x. Here's my g of x. So here's what we're going to do. We always start with the inside function. So I'm going to pretend like this g is not even there, and I'm going to find the limit as x approaches 3 of f of x. So I'm going to go up to my f of x equation. To find the limit of this, I'm going to use direct substitution. So I'm substituting my 3. So that part of my problem is 12. Now, I'm going to use this. I've done the inside. I'm going to work my way out. Now I'm going to find g of 12. So I'm going to go find my g equation, plug 12 in, 12 plus 1, 13 is my final answer. Okay, let's do another one. Again, I'm going to find the limit as x approaches 0 of f of g of x. So I always start with the inside function. I'm going to start with my g of x and find the limit as x approaches 0. So I'm going to go to my g of x equation, use direct substitution. So that part of my answer is 1. Okay, that's not my final answer. I'm going to take this answer and plug it into my outside equation or expression. So I'm going to plug 1 into my f equation. Here's my f equation. 4 times 1, so my answer is 4. So it's not real hard. Always start on the inside, work your way out. And you kind of did something like this in Algebra 2. Okay, example 5. Now they're going to throw in some trig functions. Right now, I'll let you use your trig chart. Before we take the test, we're going to review trig functions and how to find those without using your chart. Just because they're trig functions, I can still use direct substitution. So, on part A, I'm going to say the tangent of 0. So now I need to find out what the tangent of 0 degrees is. The tangent of 0 degrees, separates your y over your x value at 0. So my answer is 0. Part B, going down, I'm going to use direct substitution again. Pi times the cosine of pi. So I need to figure out what cosine of pi is. That's the cosine of 180 degrees. Cosine of 180 degrees, negative 1. So my answer is negative pi. Okay, let's go back up to part C. Sine squared of 0. That actually means this. Sine of 0 and then square your answer. The sine of 0 is 0, and when I square it, I get 0. Okay, last one. Find the limit as x approaches pi over 4 of sine x. So direct substitution, sine of pi over 4. The sine of pi over 4 is 45 degrees. Square root of 2 over 2. And I want the exact answer, not a decimal answer, so don't plug it into your calculator and give me a decimal. This is more precise, so I want the exact answer. Alright, example 6. Find the limit as x approaches 1 of x squared plus x plus 2 over x plus 1. Again, on this one, I can use direct substitution. 1 squared plus 1 plus 2 over, 1 plus 1. So that's going to give me 4 over 2 or 2. Okay, now we're going to get some where we can't use just direct substitution. Here's an example, and I know immediately I can't use direct substitution because when I plug 1 in, I get 0 over 0. We can never have 0 in the denominator. So when that happens, we have to do something else. So in your notes, it tells you what your options are. If you can't use direct substitution, our first choice, first other option, is to factor. The top, you may have forgotten, is the difference of cubes. So I'm going to factor this. Now this is one that you may have forgotten how to factor. I factor x cubed minus 1 as x minus 1, x squared plus x plus 1. Like I said, that's one of those where you may have forgotten how to factor that, over x minus 1. Now this is a really good thing because now I can cancel my x minus 1's. And I have x squared plus x plus 1 left. Now, after we factor, we always go back and use direct substitution. When I plug 1 in, 1 squared plus 1 plus 1. So my answer is 3. Okay, here's another example of where we cannot use direct substitution because when I plug negative 3 into the bottom, I'm going to get 0. So I automatically know I can't do that. So my first other option is to factor. I need to factor the top. I know it's going to be x and x. I know my signs are going to be different. And I need factors of 6. When I subtract them, I get 1 because there's a 1 in front of that x. So it's going to be 3 and 2. I know my 3 goes here with a plus because of this plus sign right here. Plus, it usually works out to where I can end up canceling something. Alright, and that's what happens here. I can cancel out my x plus 3's. I have an x minus 2 left. Now I can use direct substitution. Negative 3 minus 2, negative 5. Example 9. Okay, I cannot use direct substitution because I get 0 in the denominator. I can't factor this either. This can't be factored. So this is my third option. Use the conjugate. Remember what the conjugate is? It's the exact same thing, but you change this sign right here. So look at what happens. I'm going to multiply the top by x plus 1 plus 1. If I multiply the top by that, I have to multiply the bottom by that. This is a value of 1, so I'm not changing anything. Now, at the top, if I think about this being in parentheses, this is actually the difference of squares. And if I were to FOIL this out, just like if I FOILed out x plus 1, x minus 1, I get x squared, and then it's always minus. My middle terms cancel out, and I just get this last term squared. That's what's going to happen with this. This times this is just going to give me x plus 1. It's going to be minus in between, so this times this give me my x minus 1, or x plus 1. Negative 1 times 1, that's going to give me my minus 1. Now, on the bottom, do not try to FOIL all this stuff out. I'm just going to write x times x plus 1 plus 1. Now look at what we have on top. My 1's cancel, I just have x. On bottom, I have this. Oh, my marker is starting to mess up. Oops. So you see what happens here? My x's are going to cancel. That's a really good thing. Because now I have a 1 on top, x plus 1 left on bottom. And now I'm going to use direct substitution again. I'm substituting in 0. 0 plus 1 plus 1. So you see what we're going to have? 1 over square root of 1 is 1. 1 plus 1 is 2. 1 half. Okay, if we need to work another one like that in class, we will. Okay, example 10. The limit as x approaches 0 of tangent x over x. I can't use direct substitution because I get 0 in the denominator. I can't factor anything. I can't use the conjugate. So this must be one of our special limits. So on your sheet, if you'll look at C, let me get this out of your way, this one right here. That's one of our special limits. I automatically know that I can put the limit as x approaches 0 of tangent x over x is 1. Okay, now keep these special limits in mind when we look at the next one. I want to find the limit as x approaches 0 of sine 4x over 4. Okay, sine 4x over x, I said over 4, it's x. Doesn't that look a lot like this one? The only difference is I have a 4 right here. So if sine x over x is 1, what do you think the sine of 4x over x is? It's 4. Same thing here. This one looks a lot like that. I can actually rewrite this as this. So if this is 1, then my answer for this is 1/5. Okay, look at this one. Sine squared x means I have 2 of them. So I have sine x times sine x over x. I forgot my x here. So look, here's one of my identities, or one of my special limits. Sine x over x, that's 1, times sine x. Okay, now I can use direct substitution. Substitute my 0 in. 1 times the sine of 0. Do you remember what the sine of 0 is? Sine of 0 is 0. So 0 is my answer. I think that's the last one. Yep. Okay, so you should be ready to do the assignment. Your assignment is on your note sheets, and I will see you later.